available. If you want, you can download also. In MS Teams only, it will be available. I'll show all the path, everything, how to download later on. Let me read question because I'm recording, no? A monochromatic source S of wavelength lambda is phase rate additions of 1 by root 2 minute from the midpoint of slits as shown. Find the fringe width of interpass pattern on the screen. The distance between slits is 2 millimeter. So there's a diagram. Yeah. Within around, I think around 8 minutes, you can really crack this. What is the angle made by the plane of the slits with horizontal? It is given pi by 4. This is, you take help of this. This is going to help you a lot. This angle is pi by 4. Okay, we'll proceed like this. So this is the one ray emitted from that, so will pass to the slit and will enter point P1. The another ray emitted by source after passing through slit undergoes diffraction and so on. So he has given this distance is what? Root 2 millimeter. So there's a ray 2. There's a ray 1. So we'll cover more path before slits. We'll cover more path before slits. So it will be the ray 1. I'll draw perpendicular. This you call delta x1. Call n. We took earlier problems symbol n, so let it be n. We'll cover more path after slits. This will be, so let it be m. We have to get this, and you see this delta x2 has to be determined here. So take help of, look at the geometry. What we can do with the geometry is like, what is the given condition? You look at this, d very much less than. So let me write it very clearly. This is capital D, no? Looking at the data. Then angle made by the line joining S1P, S2P and CP with horizontal will be equal. The same earlier mathematics what we did. This will be theta, you take it. And this will be theta. And this will be theta. What can be this angle? Pi by 4 minus theta. Just only the geometry is what will trouble you. You rest of everything you can manage. This angle will be equal to pi by 4 minus theta. And this distance is how much? S12 will be equal to d, that one. So somehow, so let's calculate in the triangle S1, S2, M. So let me take help of that triangle. From the triangle, so we'll calculate what is delta x2. Then we'll see what we can do with the delta x1. So from triangle, in triangle S1, S2, M. S1, S2M in the triangle S1, S2M. So the cos of pi by 4 minus theta. Cos of pi by 4 minus theta should be equal to delta x2 by d. So where delta x2 is equal to d cos pi by 4 minus theta. This will expand delta x2 is equal to d into cos A cos B formula will apply. Cos pi by 4 cos theta d. This will be plus sin pi by 4 sin theta. So d by root 2 I'll take outside, cos theta plus sin theta. Theta will be very small, so this will become d by root 2. Theta very small, cos theta will be 1, sin theta will be theta. From where I am using theta very small condition. Okay, we got delta x2. What to do with delta x1? He's asking fringe width, you see. He didn't ask any other thing. He's asked fringe width. Okay, now what all the path difference before slits? What will happen to in the fringe width? Remains same. So let me write the net path difference. The net path difference will be delta x2 minus delta x1. The net path difference. I'll take help of mathematics. The net path difference delta x net equal to delta x2 minus delta x1. Delta x2 is how much? D by root 2 1 plus theta minus delta x1. What to do with theta? Theta we can't do like this, no? Theta very small, sin theta we can also write sin theta as theta and or tan theta. This will be further, sin theta will become tan theta, we can write it. So that tan theta, okay, write it here. This let it be tan theta. Tan theta, can I write it as y by d? D by root 2 y by capital D. D is this one minus delta x1. Okay, we are searching for the fringe width, so n lambda is equal to d by root 2 1 plus y by d minus delta x1. What to do with delta x1? We'll leave it. Put n equal to 1, calculate y1. Put n equal to, calculate y2. Take the difference. Fringe width is what? y2 minus y1. The delta x1 will get eliminated. Put n equal to 1. For n equal to 1, we'll get this lambda equal to d by root 2 1 plus y1 by d minus delta x1. For n equal to 2, the equation will be 2 lambda d by root 2 1 plus y2 delta x1. The required answer, the fringe width will be w equal to y2 minus y1. Solve for y2 minus y1, we'll get the required value for the fringe width here. Okay, so the delta x1, though we don't know that, it will get eliminated. If you ask something position, no, we can't do anything because we need further information there. So since it asks fringe width, no, so we can straight away need not to bother about calculating delta x1. So sometimes that's why you see in sometimes numericals, no, So what is the end thing needed? What is the end answer needed? And the required data, is it sufficient or not? You just do analyze. So you should not waste time in trying to calculate delta x1 because they ask fringe width. So you look at all the numericals here. When you're calculating the fringe width, the path difference before slits will not influence. Now, that's why I just picked up this particular problem. So this will be 2 lambda by d. If you solve it, you'll get some answer. And this is some major part of mathematics. I'm just showing it here only.
5 into 10 power minus 2.
5 into? Anybody answer?
5 into 10 to the
5
power
into 10
minus
power
4.
minus 4.
Minus 4 meter.
0.5 millimeter.
Okay, yeah. Now, can be asked in advance. You see, that doesn't require any much mathematics also. Some simple ideas based. See one diagram, then I'll scroll down. Anybody taking screenshot, you can take screenshots. Then I'm posting in WhatsApp group only. I'll take screenshots from laptop. I'll post in WhatsApp group because like some problem is there in MS Teams. If I do that in post, many of you are asking, sir, mobile, computable, all. It'll be a headache for me to respond for everyone. Almost some 80 students responded in the first one. So rather than responding, better to simplify things. I'll post all these screenshots in the WhatsApp group. Any other assignment I'll post in this one, MS Teams. In post we can have it, that one. Okay, that's if you're taking screenshot. You can take screenshots here. Completed. I'll proceed to next one. Okay, now one more question you have. A coherent light of wavelength